In part 3 of our seminar, we're going to be looking at corresponding angles. A postulate, remember, is something accepted to be true without proof. In this problem, if two parallel lines are cut by a transversal, then the corresponding angles must be congruent. Notice, there's a big if part here. If the parallel lines. Okay, we have to have parallel lines. If the lines aren't parallel, we can't use this postulate. So in the example we did before where the lines weren't parallel, the corresponding angles, angle 2 and angle 6, didn't have to be congruent. But if the two lines are parallel, then the corresponding angles must be congruent. On example 5, we're going to apply that to find the measure of all 8 angles. In this picture, we're told the measure of angle 11 equals 51 degrees. We can take this postulate and we can apply it to find all 8 angles. Notice it says find the measure of each angle, which is pretty basic in itself, but make sure you justify your answer. Tell me why that's true. Well, if we take a look here, the measure of angle 12 is also 51 degrees. That has nothing to do with the lines being parallel. Notice 11 and 12 are vertical angles. So that's what we're going to say. They're vertical. How about the measure of angle 13? Well, the measure of angle 13 is 11 and 13 are supplementary. So you take 180 minus angle 11, which is 51 degrees. We're going to get 129 degrees. So why? Because they're supplementary. They're a linear pair. Maybe I should write down, let's write linear pair there. That's the reason. And then we can take a look at the measure of angle 10. Well, that's also 129 degrees, isn't it? Now you have two choices, both which are correct. Why do we know angle 10 is 129 degrees? Because it's vertical to angle 13, or it's a linear pair to angle 11, or it's a linear pair to angle 12. All of them are correct. I'm just going to say vertical. Now, let's skip down to the other line. Let's find the measure of angle 14. Well, angle 14 corresponds to angle 10. Since angle 10 is 129 degrees, angle 14 is 129 degrees. We could use corresponding with all of these, couldn't we? The measure of angle 15 is going to be the same as the measure of angle 11, which is 51 degrees. The measure of angle 16 is going to be the same as the measure of angle 12, which is 51 degrees. And we'll say corresponding again. And finally, the measure of angle 17, well, that'll be the same as the measure of angle 13, which is 129 degrees. Corresponding. You can actually see for this example, we can take a look at the relationship between the other pair of angles. Let's take a look at alternate interior angles, 12 and 15. How do 12 and 15 compare? They're the same. 13 and 14 are corresponding. Notice they're the same. So alternate interior angles are congruent if the lines are parallel. How about alternate exterior angles? 10 and 17. Well, 10 was 129 degrees, 17 was 129 degrees. So the alternate exterior angles are congruent. Let's compare. How about 11 and 16? 11 is 51, 16 is 51. That seems to be a pattern here. How about same side interior angles? 12 and 14. 12 is 51 degrees, 14 is 129. Oh, they're not the same. They're supplementary. How about 13 and 15? 13 and 15, they are also supplementary. You got 129 and 51. So consecutive interior angles are supplementary. Notice vertical angles and linear pair have nothing to do with lines being parallel. They're always going to be congruent and supplementary. Vertical angles are always congruent. Linear pair are always supplementary. Has nothing to do with parallel lines, but the other ones are true. And here is what I just said. These are all three theorems, which means we can prove them. I've done the proof for alternate interior angles because all we do is we use corresponding angle postulate to get that. That is, if the lines are parallel, I want to prove angle 4 is congruent to angle 5. So what we do is we start with angle 2 being congruent to angle 4 because they are alternate interior angles. Well, 2 and 5 are congruent by vertical angles. So 5 and 4 are congruent by the transitive property. Because if two angles are congruent to the same angle, they're congruent. Let's take a look at example 6 here. It says the diagram represents floor tiles in Michelle's house. And we're making an assumption here, since these are floor tiles, we're going to say these lines are all parallel. So I'm going to put arrowheads on here to remove any doubt. Our assumption is, since they're floor tiles, that the lines are parallel. If I put 2 arrowheads on a set of parallel lines, they're parallel, just means they're not parallel to the ones with 1 arrowhead. We're told angle 2 is 125 degrees. We're supposed to find the measure of angle 3. If we look at our picture, angle 2 and angle 3, they're alternate interior angles because they're connected by the transversal and they're on the opposite side, they're inside our other lines. Since they're congruent, angle 3 is 125 degrees. On example 7, we're going to do a little algebra here, still using the same process. We are comparing angle 5 and angle 7. And once again, we're still using... Oh, I got the wrong picture there. So we're going to throw this one out. That picture doesn't make any sense. There's no 5 and 7. Let's take a look at angle 8 instead, or example 8 instead. Angle 1 is 9x plus 6. Angle 2 is 2 times 5x minus 3. And angle 3 is 5y plus 14. We want to find y. Notice I threw a little wrench at you here. Angle 1 and angle 2 are in terms of x. Angle 3 is in terms of y. You can't solve an equation that has both an x and a y, at least not a single equation. You can solve a system of equations. So let's start with angle 1 and angle 2. Notice we got some parallel lines here. A is parallel to B. C is parallel to D. What's the relationship between 1 and 2? Well, 1 and 2 are alternate exterior angles. So I know since they're alternate exterior angles, I know they're congruent. So we know the measure of angle 1 equals the measure of angle 2. So we're going to say 9x plus 6 equals 2 times 5x minus 3. Well, let's distribute. So 9x plus 6 equals 2 times 5 is 10x minus 6. Let's get all the x's on the same side. And like I said in my last seminar, I always like to move the smaller x. So I'm going to subtract 9x from both sides. When you subtract 9x from both sides, the 9x's on the left cancel. And we're left with 6 equals x minus 6. Well, let's add 6 to both sides. So 12 equals x. That's not what we want. We want y, but we know 12 is x. Well, let's find angle 1. The measure of angle 1 is 9x plus 6. So we're going to take 9 times 12 plus 6. Well, 9 times 12 is 108. Just make sure my mental math is right. 9 times 12 is 108. Plus 6 would be 114 degrees. So angle 1 is 114 degrees. Angle 2 is 114 degrees. Now notice if we use B as my transversal, lines C and D are parallel, angle 2 and angle 3 are congruent. So in other words, angle 3 is also 114 degrees. But now we can solve for y. Since angle 3 is 114 degrees, we can say, oh, 114 equals 5y plus 14. Now let's do the algebra. Let's subtract 14 from both sides. And we get 100 equals 5y. Divide both sides by 5. Y is 20. And since this is a multiple choice question, it would be choice C. But as you can see, see the C? You have to show work. Do not just write down C and expect me to believe you understand how to do this. Show me some work. The last theorem we're going to take a look at is called the perpendicular transversal theorem. Kind of a fancy name. So it means we'll probably use it once in a while because it has its own name. And what it says is if you have two parallel lines and your transversal is perpendicular to one line, then it has to be perpendicular to the opposite line. Of course, that should make sense because, hey, if you have two parallel lines and perpendicular means one angle is 90, we know the corresponding angles are congruent, so the other angle is 90, which makes it a right angle.